Hello.
Yes, sir. Good evening.
Yeah. Good evening. Have you looked at NCERT book for integrals?
Yes, sir. I have a few doubts in the question.
Send the doubts on WhatsApp.
Yes, sir.
What do you have to find here?
So we have to integrate it with respect to x.
Okay. First of all, do you have any other questions?
Yes, sir.
Send all of them. Okay. Is there anything else?
Yes, sir. I have a doubt in a paragraph from the theory part.
Okay. Fine. We'll discuss what has to be done. So first of all, do you know what the meaning of integrate is?
Yes, sir.
What is the meaning?
Finding the antiderivative of a function.
Right. So first of all, we need to understand what is an antiderivative, right? So
Yeah.
if you think about it, earlier we have learned the process of derivative. So if we have y is equal to fx, you can find a new thing dy by dx is equal to f dash x, right?
Yeah.
This is the derivative of f. This is a new function that is the derivative of f, right?
Yeah.
And we understood earlier that derivative basically means the slope of the curve, right?
Yes, sir.
Instantaneous rate of change of this function at a particular point will come from this function, right?
Yeah.
So this process is fairly easy. If you have f of x, you can do the derivative and you will get f dash x, right?
Yeah.
Now the question is, can we do the reverse process, right?
Yeah.
So basically, if somebody gave you f dash x, this is given, and asked you what is f of x, right?
Yes.
That reverse process is called finding an antiderivative, right?
Yeah.
In the normal derivative or differentiation process, what you do is take the function and do the differentiation of it and get this. So the derivative was unknown and the function was known, right?
Yeah.
Now what we are doing, we are saying the derivative is given to you. You have to find the function which produced that derivative, right?
Yes, sir.
Basically the opposite operation, correct?
Yeah.
So obviously, like if you think about it, the opposite operation is not so easy to do. For example, x squared derivative is very easy, right? It is
Yeah.
2x, right? But if somebody gave you 2x, you have to sort of guess, no, that this will be x squared, right?
Yeah.
So the opposite operation is difficult to do in the sense that it is sometimes hard to guess what function will be whose derivative is 2x, right?
Yeah.
So when I am saying this symbol integral of f of x dx, what this means is, let's say it is equal to gx, right? What this means is gx is the function whose derivative is f, correct?
Okay. Yeah.
Are you understanding what I'm saying?
Yes, sir.
So the way to, and the way it is written is with this extended s sign, and this is called an integral sign, and it is with respect to the variable x. So that's why you write the dx. Okay. So basically this means that derivative of g with respect to x should be f, right?
Yeah.
Basically, so we have to find that function g whose derivative is f, and f is given to us, correct?
Yes, sir.
So normally by guessing, you can figure out some standard integrals. For example, because we know that because we know the derivative of some of the functions, we can guess the integrals. So for example, d by dx of x power n was n x n minus 1, right?
Yeah.
So from here, it should be obvious that integral of n x n minus 1 dx should be x power n, right?
Yeah.
Because that is the meaning of the operation, right?
Yes, sir.
So from this, we can say that this n is a constant and we can take it outside and we can say n x power n minus 1 dx is x power n. So n can be brought down here. So you get this thing, x power n minus 1 dx integral is x power n by n, right?
Yeah.
So in order to make it a formula, instead of n minus 1, I should put n here. So it will be x power n. Instead of n, I'm putting n plus 1 basically. So it will be here, it will be n plus 1 by n plus 1, right?
Yeah.
Do you understand how we have gotten the integral formula?
Yes, sir.
We are getting it by looking at the derivative and doing the reverse operation, right?
Yeah.
Integral of this should be this, and from there only we figured out the formula for this, right?
Yeah.
And also, why is there a constant added to it? Do you know that? Why?
Yeah.
The reason is that if you differentiate x square plus 1, the derivative of x square plus 1 is 2x. The derivative of x square plus 2 is also 2x, right?
Yeah. It's an arbitrary constant to differentiate
Right.
all the derivatives from each other, or else we'll get confused which one is which.
So basically what we are saying is all of these functions have the same derivative, right?
Yeah.
So when you do integral of 2x, it can be anything, right? Any of these, right?
Yes, sir.
Do you understand? Because this operation is all pointing to one thing, right? So the
Yeah.
reverse operation can also be anything, right?
Yeah.
It could be x square plus 1, it could be x square plus 2 also actually, right? So in
Yes,
order
sir.
to specify it, we say integral of 2x dx. In general, we can write as x squared plus c because any constant is fine, right?
Sir.
Because the derivative of a constant is 0. So if you differentiate this side, you will get 2x no matter what the constant c is, right?
Yeah.
So the first formula that we have gotten is by using the derivative of x power n and figuring out, okay, what will be the reverse operation? We got this formula, right?
Yes, sir.
Similarly, we know derivatives of sine x, for example, is cos x, right?
Yeah.
So now we can say integral of cos x will be sine x plus c. right?
Yeah.
Similarly, derivative of cos x is minus sin x, right?
Plus C. Yes.
No,
Sorry.
derivative doesn't have a constant, right?
Yeah.
Similar, so you can say from here only derivative of minus cos x would have been sin x, right?
Yes, sir.
Because the constant is just going to be there. It doesn't matter, right?
Yeah.
So from here we can say integral of sin x is equal to minus cos x plus c,
Yeah.
the opposite operation, right?
Yes, sir.
Similarly, derivative of tan x was secant square x. Derivative of tan x was secant square x. So therefore, integral of secant square x will be equal to tan x plus c,
Yeah.
right? So
Yes.
we have a table of derivatives, and from there we can construct a table of integrals also, right?
Yes, sir.
So integral of e power x will be equal to e power x plus c.
Yeah.
Okay, so this basic table of integrals should be clear to you. Right now, what we will learn is one major method, which is the only method that you need to know right now. Later, we'll learn new methods of integration. But the main method here is integration by substitution or change of variable. Okay.
Yes,
This is
sir.
a major method of integration or change of variable, which is super important because then you can integrate some basic things like the ones that you have sent me. Okay. So what is this method? So first of all, you have to realize that you will have a table of basic integrals, right?
Yeah.
Those basic integrals you need to know, like these ones: sine, cos, tan, sine, cos, secant square x, right?
Yes, sir.
Secant square x was giving us tan, right?
Yeah.
And your e power x and your x power n, right?
Yeah.
So those basic integrals we need to know, and we will be using those integral formulas only in order to find out or in order to calculate new integrals. Okay. These
Yes, sir.
basic formulas will be used when we find out different integrals. Okay. So for
Okay.
example, suppose you have x power half, right? So by
Yeah.
the formula of x power n, you get what? X power 3 by 2 by 3 by 2 plus c, right?
Yes, sir.
So it becomes 2 by 3 x power 3 by 2 plus c, correct?
Yeah.
And how do you check whether your answer is correct or not? You can always check by differentiating this and seeing whether it is matching this or not.
Okay.
Do you understand?
Yes, sir.
If you do an integration and you do the differentiation of the final answer and it doesn't match the initial integral function, then you have made a mistake somewhere, right?
Yeah.
Because the two operations are absolutely reverse of each other, correct?
Yes.
Now let's look at trying to find out integral of tan x dx. Okay. Also, by the
Okay.
way, you need to know one thing, the integral of 1 by x dx. This is a formula that you need to know. It is log x plus c. Because
Yeah.
1 by x doesn't fit into the pattern of x power n dx, because if n is minus 1, the formula is not going to make any sense, right?
Yes, sir.
Do you understand that n not equal to minus 1, this formula is fine, right? But
Yeah.
when n is minus 1, the denominator becomes 0, right?
Yes, sir.
So this is an integral formula that you need to be aware of, okay?
Okay.
So this also means that the derivative of log x is 1 by x, right?
Yes, sir.
How does that make sense? Derivative of log x is 1 by x. That makes sense because the e power x function and the log x function are inverse of each other. Here, when I say log of x, it is to the base e, okay?
Okay.
Do you know basic logs and all?
Yes, sir.
Okay, so when you say log x is equal to t, what this means is actually x is equal to e power t.
Yeah.
Do you know this?
Yes, sir.
Okay. So now the meaning of inverse of each other means two functions are inverse of each other if when you compose them together, f of g of x, they will give us x. Or g of f of x will also give us x.
Okay.
That means the two functions are cancelling each other's effects. Okay.
Okay.
Do you understand what I mean?
Sir, so the differentiation function and integration function are also inverse of each other.
There is a difference between functions. Functions being inverse of each other is this rule, right? They cancel each other's effects. But integration and differentiation are not functions, they are operations, right?
Yeah.
They are like one person added, other person subtracted. These are operations, right?
Yeah.
Correct? These are
Yes.
operations which are reverse of each other. That is correct. But here we are talking about functions which are inverse of each other. For example, two functions which are inverse of each other are x square and another function is root x, right?
Yes, sir.
Basically, if you do f of g of x, where f is x square and g is root x, you will get f of root x, and then f of root x will become root x square, right?
Yes, sir.
And output is coming as x only, right?
Yes, sir.
So basically, if you take two functions f and g which are inverse of each other, if you input x here, you get f of x. But if you input f of x to the g now, it will give you back x. Because
Okay.
g cancels the effect of f, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
So log x and e power x, y is equal to e power x and y is equal to log of base ex. These are opposite operations. For example, if you take an input, let's say we have to find f of g of x, right? Where f is e power x and g is log x, right?
Okay.
So what will happen? We'll write it as f of log x, right?
Yeah.
That will be e power log x, right?
Yes, sir.
And now think about it. This is e power log base ex, right?
Yeah. So
That
the
is same as
basis.
x, right?
Yeah.
Why? Because the meaning of logarithm was log base ex is the number which, if you raise the base, if you raise e to that number, it should give you x, right?
Yes, sir.
It should give x, right? So
Yeah.
log ex is that number. If e power that has been done, then you get x, right?
Yeah.
So here what is happening? E power that number only. No?
Yes, sir.
Do you understand?
Yes, sir.
So they are inverse of each other. Log f of x and log x and e power x, right? And now I
Yes.
will prove for you how the derivative of log x is 1 by x. We can now do the proof. Because they are inverse of each other, we know the rule that f of g of x would be x, right?
Yeah.
Right. And let's call this as g and this as f, right?
Okay.
So if I differentiate this by chain rule, I will get f dash g of x, g dash x is equal to 1, right?
Yeah.
So g dash x is equal to 1 by f dash of g of x, right?
Yeah.
So now let's do it because we know f function and its derivative. We can find what is f dash g of x, right? So f function is e power x. So f dash x is what? E power x only, right?
Yes.
So f dash of g of x would be e power of g of x, right?
Yes, sir.
But g of x is log x, right? So this is
So
equal
e-
to x. So we are
yeah.
getting this, no.
Yes,
So we
sir.
are getting that the derivative of the logarithm function is 1 by x, right?
Yeah.
So this is the proof. Because these two functions are inverse of each other, we have used the composite function method and done the chain rule. And from there, we have found the derivative of the log function, right?
Yeah.
I hope you are understanding what I'm saying.
Yes, sir.
So if the derivative of the log function, we know that log function d by dx is 1 by x. Now we can confidently say that integral of 1 by x is log x, right?
Yeah.
So now this becomes another integral that you need to remember. This is another integral added to that table, right?
Okay.
And now we can solve, now we can learn about the substitution method. So suppose we have to find integral of tan x, right?
Yeah.
This was one of the questions you have asked, right?
Yes, sir.
So let's say tan x can be written as sin x by cos x, right?
Yes.
Now what I would want to do here is change my variable and change my variable in a way that I am able to get an integral from the table that I know, right?
Yeah.
Because if you see the table right now, I know only sin x integral, cos x integral, secant square x integral, e power x integral, log x integral, and x power n integral, right?
Yes, sir.
Literally, there are only 6 I know, right? So
Yeah.
I need to somehow use, and I also know not log x integral, I know 1 by x integral, not log x. This is what I know, right?
Yeah.
Correct? No? This is what I know.
Yes,
So
sir.
this is my table of integrals. I can only use this much. So I have to figure out how to use it somehow. Okay.
Okay.
So what I will do is I will say, let's take cos x as a variable called t now. Okay.
Okay.
If I change the variable, I'm changing cos x and I'm calling it t, right?
Yes, sir.
So if I differentiate this, you will realize that you will get do differentiation on both sides here. Okay. So you will get dt right here, dt by dx, right?
Yeah.
So I'm doing derivative with respect to x. So this part will become dt by dx should be equal to minus sin x, right?
Yeah.
So what we get is dt is equal to minus sin x dx, right?
Yeah.
Are you understanding this step from here?
Yes, sir.
So notice that on the top part here, there is a sin x dx, right?
Yeah.
So now I can replace that with minus dt
By T.
by t, right? And the minus
Yeah.
sign is a simple constant which can be taken out, and I'll have a dt by t, right?
Yes, sir.
But that is one of the formulas, correct?
Yeah.
So the formula for this is log t, right? Log x, right?
Yeah.
So this should be minus of log t plus c, right?
Yes, sir.
And now t I will put back in terms of x because I started with a question in terms of x. So I'll put back t is equal to cos x, right? So I get minus log cos x plus c, right?
Yeah.
And minus 1 log cos x, by properties of log, it can be written as log of cos x power minus 1, right?
Yeah, which is sec x.
So log sec x plus c you get.
Understood.
So basically the main thing is you have to be clever about it and change the variable in such a way that you get to use your formulas, right?
Okay.
You cannot do any integral whose formula you don't know, okay? And we know only a limited number of formulas, right? So
Yeah.
all the methods that we will have, and especially this method, the substitution method, is about being smart about it and changing the variable in such a way that it becomes a nice integral. Okay. So
Okay.
here sin x by cos x, we changed by looking at cos x as t because it made sin x dx as dt,
Yeah.
right? And it became dt by t, right?
Yes, sir.
So now let's look at the other one also that you sent. That one is integral of, we have to do tan power 4 root x sec square root x divided by root x, right?
Yeah.
So first of all, I don't like the root x and all, right? It would have been
Yes.
nice if there was x instead of root x, right?
Yeah.
So my first substitution will be removing root x by calling it t. Okay.
Okay.
So if I do this, I'll have to change my dx also. So I have to differentiate both sides here, right? So
Yeah.
dt by dx will be what? Root x derivative, tell me.
-1 by x square.
No, you're saying wrong. Root x is x power half, no? So dt by dx by power rule will be half x power minus half, right?
Oh, right, right.
N x power n minus 1, right?
Yes.
So this is what? 1 by 2 root x, right?
Yeah.
So notice one nice thing is happening. You can take the 2 this side, 2 dt is equal to dx by root x.
Yeah.
Correct? And already there is a dx by root x here, right?
Yes, sir.
So my integral will become nicer now because I'll replace everywhere root x. So I'll get tan power 4t secant squared t and dx by root x is 2 dt.
2 dt.
So the integral has converted into a t integral now, right?
Yes, sir.
And it looks like this. I can take the 2 outside because it's a constant, right?
Yeah.
Are you understanding that this is the question now?
Yes, sir.
So what was the logic? How did I think of this substitution? The main idea is I don't want root x, okay? And I
Okay.
tried to do the substitution and then automatically the question was designed in such a way that dx by root x got replaced, right?
Yeah.
I hope you are understanding.
Yes, sir.
But now there is still a problem because you see your table of integrals, there is no formula for this. There is no
Yeah.
formula in your table for tan power 4 into sec square, right?
Yes, sir.
All you know in your table are sine, cos, sec square, right?
Yes, sir.
Great. So what we will do is we will now do another substitution. Okay.
Okay.
We will say that first of all, notice one thing, tan's derivative is what? D by dt of tan would have been sec square t, right?
Yes, sir.
So sec square t and dt is present here. So that should give you the hint that maybe I can take tan t as a new variable u, right?
Yeah. Yes,
Because
sir.
then if I do du by dt, I would get in this side sec square t, right?
Yeah.
By derivative, both sides, this is what is coming, right?
Yes, sir.
So can you see that sec square t into dt becomes du,
Yeah.
which is very nice because now I can convert the integral and it looks like 2. This I will put as u power 4, right? And
Yeah.
this I will put as du, right?
Yes, sir.
And now it is following a formula that we know from the table.
Yeah.
X power n dx, right?
Yes, sir.
So the answer will be 2 by 5 u power 5 plus c.
Yes, sir.
And now I have a u answer in u. So what you have to do is convert u to t and then t to x.
Yeah.
So my answer will be 2 by 5. U is tan t. So I'll put tan to the power 5 of t, right? But t was what? Root x, right?
Yeah.
This is the final answer.
Okay, sir.
So the whole integration was done by two different change of variables. One was this, and the second one was this.
Yeah.
And that is the main thing, that is the main technique or skill which comes with practice and experience. You have to learn how to, okay, what should I do? It's a tricky thing sometimes, but you have to learn by practice how to convert an integral into a nice form and do it, right?
Yeah.
So the table will not be endless. You'll have only 5, 10 integrals, that 10, 12 integrals you'll remember. And after that, you have to use your brains to figure out what to do. Okay.
Okay.
For example, another integral that appears in physics, for example, this integral. This integral will appear in chapter 8 of HCV, chapter 9 of HCV. Okay. So
Okay.
we are doing this integral because it comes in physics. So let's see how to do this, right?
Okay, sir.
So right now there is no formula for sine cube, right? You don't know any formula for that, right?
No, sir.
So we have to think of some nice substitution, right?
Yeah.
So what I will do is I will use the fact that I know this stuff. I know this is 1, right?
Yeah.
And I also know the derivative of sine was what? Cos t.
Cos t.
So maybe I can use that somehow. So let's see how. Sine cube can be written as sine square t times sine t, right?
Yes, sir.
And if derivative of sine was cos, we know derivative of cos was minus sine, right?
Yes, sir.
So notice that sine t dt is present here, no?
Yeah.
So if I am able to write this as a cos, then I can do cos t as u or something, right?
Yeah.
So what I will do is simple. I will write sine square as 1 minus cos square t here, right?
Yes, sir.
And keep the sine t dt as it is, okay?
Okay.
And now, because my cos derivative is sine t, I will say u is equal to cos t, right?
Yeah.
So what will happen? Du is equal to minus sine t dt.
Yes, sir.
So this sine t dt will become minus du.
Yeah.
And this will become 1 minus u square, right?
Yeah.
And now I'll have basically u square minus 1 du, right?
Yeah.
Which can be split into two separate integrals, u square du minus 1 du, right?
Yeah.
And this is u cube by 3 minus u plus c, right?
Yeah.
And now you put back the u is equal to cos t, you get cos cube t by 3 minus cos t plus c.
Okay.
And how do we know that this is correct or not? If you don't
I
believe it, you can
differentiate.
differentiate this,
Yes,
right?
sir.
Let's differentiate it. Cos cube t by 3, it will be 1 by 3, 3 cos square t, and then derivative of cos, which is minus sine t, right?
Yeah.
And then minus minus, so plus sine t.
Yeah.
So you are getting cos square t into minus sine t plus sine t, right?
Yeah.
So sine t common, it will be 1 minus cos square t, right?
Yes, sir.
Which is sine cube t.
Yeah.
Do you understand what we are doing?
Yes, sir.
So this integration by substitution is the most important method of integration that you need to know. I want you to practice from the NCERT book. There might be 1 or 2 exercises which have simple questions based on this. Okay.
Yes, sir.
So what you need to do is practice some exercises, the basic exercises. Don't worry about integration by parts. At some stage, they will introduce a technique called by parts. Okay.
Okay.
We will not be discussing that right now. It's not required right now. Okay. So
Okay.
if there is a section on by parts, ignore it. Okay. And
Okay, sir.
just focus on this. And then if you are done with that exercise, you can go to the next chapter, which talks about a definite integral, a to b fx dx. Okay.
Yeah.
Whichever section is talking about definite integral, you need to go to that. Okay.
Okay.
Definite integral, and it will define it as an area under a curve. Okay. So
Okay.
what you need to do is a little bit of the exercise for basic integration, which you have already started, right? And
Yeah.
then move on to the next section, which talks about integrals where there are limits assigned a to b fx dx, which is known as a definite integral, and it is also understood as area under the curve. So that is the part that we want to discuss on Friday. Okay.
Okay, sir.
Once we discuss that and we understand what is the meaning there, then we are done with the calculus that is required. Okay. So
Okay.
obviously, this is like a very fast, we are doing it very fast, but what you can do is you can continue working on the NCERT calculus sections from limits, derivatives, integrals yourself slowly, right?
Yes, sir.
Nobody is stopping you to do functions, limits, derivatives, application of derivatives, maxima, minima, integrals, definite integrals, all of the chapters, right? You can
Yes,
do
sir.
it yourself on your own time. If you have doubts there, we can solve it later. But that is not part of our physics course right now. Okay.
Yes.
For the physics course, we need to understand definite integral and then we'll move on to physics from next week.
Okay, sir.
Okay, so focus on what we discussed today. Read the theory a little bit and it will be fine. Okay.
Okay.
Okay, fine. That's all for now then.
Thank you, sir.
Mhm. Bye.